Okay, so yeah, I think I'll start then, and I'll just dive into the slides. And like I said, what I'm going to do is I'll just do like 15 minutes, and then I'll stop and have questions, and then I'll do another 15 minutes and stop and have questions, and then at the end, I'll just have open-ended questions for anyone who wants, that. So, right, okay, so this is domain modeling made functional. And I'm Scott Wlaschin, and thank you so much for having me. I really appreciate it. I have a website, F# for Fun and Profit, for if you don't know about that. I like using F#, but in fact, the concepts here are not actually F# specific. You could do the same thing in Rust or in Scala or in Elm or even in JavaScript. I'm going to use F# for my examples, but they're not F# specific, So, functional programming. This is going to be a little bit about functional programming, and people have a bad idea about what functional programming is. They think it's really good for mathematical things, and that's really not true. So I don't like to say that. I actually think functional programming is very good for interactive and collaborative domain modeling. And that's not what most people think of functional programming being good for. But I'm going to try and persuade you by the end of the talk that this is what it is good for. So in particular, it's really good for representing a domain model accurately. So if you're into domain-driven design, I suggest that you look into functional programming because I think it might help. So here we go. We have functional programming and we have domain-driven design, and I think they're a perfect match. So that's what this talk is about. Now, before I even start talking about code, I want to talk about design. Okay, why is design important? And the way I like to look at it is, if you think about software development, it's a process, just like any other process. And just like any other process, there's an input, and then you do something, and then there's an output. And we love to talk about the process bit as developers. We like to talk about our tools, our favorite languages, our favorite editors, different testing frameworks, and different, continuous integration and all these kinds of things. And that's important. But there's this phrase called garbage in, garbage out, right? So no matter how good the coding and the testing and all that stuff is, if you have garbage in, you're going to have garbage out. So no matter how good your programming language is, if the input to the process is bad, you're going to have bad output. Whether you're using Haskell or whatever, it doesn't really matter. So the idea is, if we can reduce the garbage going in, then we will have reduced garbage coming out. So the better we can have the input, the better we can have the outputs. The more successful the project is going to be if you have good input. And that's what I'm going to call design. So design is everything before you start coding. So that could be architecture, it could be requirements, it could be code design, whatever, but all the stuff which is not coding and testing and deployment. And this is what I really think we should focus on a lot more as developers. We like to focus on, our favorite tools, but we really should be spending more time focusing on this. So thinking before you start coding, or understanding before you start coding. There's no point just starting to code. You should understand what you're doing before you start coding. So that's the main thing I just want you to remember from this talk is think. Don't just start coding. So how can we do design right? What's the best way to do design? And I'm not going to say there is one best way, but I'm going to take a couple of ideas from agile development and from domain-driven design. And from agile, I am going to talk about the idea of doing rapid feedback, because the whole point of agile development is you do things very quickly. You have these very short sprints. You try and get feedback as fast as possible. So that's good, because you learn. The faster you have feedback, the faster you learn. Now, from domain-driven design, I'm going to take the idea that there's this shared mental model that everybody on the team is part of. And not just the code, not just the developers, but the product owners and the user interface people and the testers, and everybody involved has the same shared mental model. And that shared mental model is also in the code. It's not just, in people's heads. Okay, so I have a little picture here, and we have this shared mental model in the middle, and we have the developers, and we have the product people, and we have the domain experts, and we have the customers, and everybody else, and they all have this shared mental model. They all use the same language, the same concepts everywhere. So that to me is the core principle behind domain-driven design. And I really do think if people do not have the same ideas, the project is going to fail. Because if people aren't communicating properly, if they don't share the same language, if they don't share the same concepts, there's going to be a lot of miscommunication. And in my experience, that often is the major cause of failing projects. Not to do with having bad tests or having bad code. It's that you're building the wrong thing because you don't understand what you're supposed to be building. So if people don't understand each other, you're much more likely to have a failed project. So we got to have a shared mental model, and the shared mental model should be in the code. And if you can have the code represent the domain model, that sort of acts as documentation as well. You don't need to have a separate documentation. I mean, obviously you do at some point, but the idea is that the code represents the domain model as well. So anyone who comes on board, they can look at the code and they can understand what's going on. So the common language you use is in the code, not just in your head. Right. So when I say this, people normally say, well, that's a nice idea, but can you really make code represent the domain in a nice way? Because we all know that this is what code looks like. This is what, especially what non-developers think that source code looks like. And this is what some C developers also think that source code should look like. And of course, this is impossible code to understand. Nobody can understand this code. So this is not the kind of code I'm talking about. The kind of code I'm talking about looks like this. Okay, so this is F# code. I just want to show you, you have to kind of guess, even if you don't know anything about F#, you have to guess what this code is all about. Okay, so hopefully, even though you don't know F#, there's you're getting some idea of what this code is about. And I think you can tell it's something to do with a card game. It says card game right at the top. And these are all the concepts in a card game, right? We have this shared language. There's a concept called a heart card. There's something called a deck and a player and a game. And all these concepts are right here as kind of documentation, but this is also code. So this is code and documentation at the same time. So let me just go through this for people who don't know F#. And this is how I can explain it to non-developers as well. So vertical bar is a choice. So a suit is a club or a diamond or a spade or a heart. When you have a little star like that, means a pair. So a suit and a rank, a combination, that's a particular card. We have a nice list type, which is built into F#, very nice. And then when you see an arrow like this, that represents a workflow or a story or an action or a use case. And we're going to represent this as functions. So a function has an input and an output. So let me show you what I mean. Let's say I want to model dealing a card. So when I deal a card, I start off with a deck of cards, and after I've dealt the cards, I now have a new hand, a new card on the table, and the deck itself now has a missing card. And because in functional programming, everything is immutable, I can't just mutate the deck. I make a copy of the deck with that card missing. So the output of the function has the new smaller deck as well. So this is how you'd represent dealing a card using a functional approach. So in F#, we'd write it like this. To deal, the input is a deck, and the output is a pair. It's a new deck, modified deck, and a card on the table. So this is how we'd represent, like I say, an action or a story or a workflow using a function. Let's say we want to model picking up a card off the table. So when we pick up a card, we start off with a card on the table, and we have our hand that we're holding, and we pick up the card, and now we have a new hand, and the card is no longer there. So again, we don't mutate the hand, we make a copy of the hand with the card added, and the card on the table is now missing. So in a functional domain, we'd write it like this. We say to pick up a card, the input is a pair of things, the hand and the card, and the output is the new modified hand. So this is how we would model not just nouns, but also verbs, activities. So here is the complete domain for the card game. And I've got a couple of questions for you. The first question is, do you think this is a reasonable amount of code to write to capture this domain? And I think yes. I think the answer is yes, because the whole domain fits in one page. We have 9 things, and it all fits on one page. I don't have to go to 20 different files. So that's very nice. It's very compact. Do you think a non-programmer could understand this? So someone who isn't a programmer, is a product manager or a user interface person or just an expert, a card game expert, could they understand this? And I think it is true. I actually have done workshops with people where I have all sorts of people in the room. And one comment I heard from somebody who was a product owner was, where is the code? They said, this is very good documentation, but where's the code? So they didn't even think of this as source code because it doesn't look like source code, but they could totally understand it. And do you think non-programmers could provide useful feedback? If you're an expert at playing card games, could you notice the deliberate mistake? There's a deliberate mistake, and I think even somebody who is not a programmer but is someone who's good at card games would notice what the mistake is. And the mistake is that we're missing the ace. So that's the kind of thing that a non-programmer can give you very good feedback on. And when I've done workshops with people with domain experts, they can often provide this kind of feedback saying, oh, you forgot to handle some special case, or you're missing something important. And they can give this feedback even though they are not programmers. So this feedback is really, really important. This is what I want to get to, is that having rapid feedback is very, very important in programming in general. Now in Agile, we want to have rapid feedback. So we have very short sprints. We try and get something out the door in 2 weeks or maybe in a week or even less than that. But in a design process, you can actually get feedback in minutes rather than days. And if you can do that, that's fantastic, because the faster, the better, right? So here we have, let's say we have a workshop of doing stuff, and typically I'm typing stuff up on the board as we're talking. It's an interactive process, everybody's involved, and it's a great way to learn the concepts. So part of the process is not just to document stuff, but to understand, to all build the same shared mental model, to all be using the same vocabulary, to have the same concepts. So typically I'm going along and I'm writing something like, oh, a deck is a list of cards. And, to deal, we start with a deck and so on, just like I showed you. And I'm typing this up on the screen, and an expert will probably say, that's actually not right. They say, this deck thing, that's actually not right. When we deal with cards, we have a shuffled deck. And normally I don't know anything about the domain because I'm not an expert. So I say, okay, a shuffled deck. So like this. So I've just changed the code on the fly, and they say, yeah, that's right. And now, because I don't know anything, I say, well, okay, so what's a shuffled deck? What is a shuffled deck? And they say, well, a shuffled deck is just a list of cards, right? Now, what I do here is I put it down as a different concept. It's not the same concept as a normal deck. A shuffled deck is a different concept. It has a different behavior than a normal deck. So even though they're represented by the same concept, a list of cards, they're both a list of cards, but a shuffled deck is somehow different from a normal list of cards. It's a very important concept when you're playing a game of cards. So, okay, so I have a shuffled deck. Now, I will say, okay, well, how do you make a shuffled deck? And they will say, well, you shuffle the deck, and they often look at me like I'm stupid because I'm asking silly questions. But, if I'm not a domain expert, I'm trying to learn the domain. And so I add this, okay, to shuffle, you start off with a normal deck and the output is now a shuffle deck. So this process of, as I do this, I'm learning more and more about the domain that I didn't know about when I started. And as we go along, the domain gets documented. But this feedback happens very, very quickly. It happens in minutes, not in days, not in weeks. And by the end of the session, after a few hours of this, everybody in the room is using the same words and has the same concepts. And the developers have the same concepts as the domain experts. So at the end of this process, even if you don't know anything about playing cards, these concepts like shuffling and dealing cards, everybody would know what they were and they would be documented. So this is what I like about this process. It's very fast, it's very interactive, and it's a lot of benefit. So I'd encourage you to try doing this if you're trying to do domain-driven design. So the final version of the domain now with the shuffle deck looks like this. So there's a few extra new concepts that we didn't have a few minutes ago. And I want to point out a couple of things. First of all, this is domain-driven design. It's not database-driven. Okay, nothing in here is about storing things in a database. There's no tables, there's no foreign keys, there's nothing to do with joins. Everything here is to do with the domain, right? It's domain-driven design. And the domain-driven design people have a concept called persistence ignorance, which means when you do a domain, you should not care how it gets stored in a database. Now, obviously, in a real program, you're going to have to store it at some point, but that is not part of the domain logic. That's part of infrastructure logic or something, right? That's not part of this logic. It's part of something else. So it doesn't mean you don't have it. It just means it's not here. The other thing about this is not object-oriented. So there's no base classes, there's no managers, there's no factories. If you were object-oriented, you might say, well, a deck and a shuffle deck have a lot in common. So let's have a Boolean between the two, or let's have a subclass of two different things. And it's like, no, there's no such thing as a base deck, you know, or an abstract deck. They're two different concepts in the domain. They might have the same representation, but they're two different things. And I'll be talking about that in a minute. So here we are in the real world, we have these concepts. And what we want to do is in our code, we have the same concepts. And that's what we're trying to do. In our code, we capture the same concepts as in the domain. So that's good. They should always be in sync. And as we learn new things, like if we learn something about the domain, like this shuffle deck or shuffle, whatever, we add that to our code. The code reflects the domain. So this is domain-driven design. Okay, now this is the right way of doing it. Now, what you shouldn't do is the other way around. Okay, so let's say that you're a programmer and you say, well, you know, we need a controller to manage all these different players, and we need the base class because there's a deck and a shuffle deck, and we need an abstract card proxy factory bean because we're using Spring or something. It's like, no, that is wrong. Those things are not part of the domain. Now, they might be important in the code in implementation at some point, but they're not part of the domain logic. They shouldn't be in the domain. So don't contaminate your domain with implementation details. So the design is the code and the code is the design. This is something that we always strive for as programmers, because the more accurately the code doesn't go out of sync, right? I mean, you know, if you can have the design in the code, it's always up to date. And if you have UML diagrams or Microsoft Word documents, I mean, they always go out of date. This can never go out of date because this is the code. And typically in an F# project, this would be the first file in the project, and all the other code would like depend on this file. So they could never get out of sync. Okay, so this is executable code, not pseudocode, which is what I really like about it. So, and again, it's not just about the process of doing this and delivering a documentation. It's about building the shared mental model so that everybody on the team uses the same words, the same concepts. I can't stress this highly enough. This is the most important thing about building a successful project. So there we go. Process, 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 building a shared mental model. Collaboration, yeah. Talking to people, talking-based development, conversation-driven design. Another way of thinking about it. So communicate the design in the code is the key principle that I'm going to talk about for the rest of the next 40 minutes or so. So I've got a little challenge for you, and then I'll answer questions. Here is a record, and this is a contact, and there's a name and an initial and a last name and an email address and verified flag, and it's not very clear what that does. And my question is the design communicated in this code? You know, all the important things about the design, is it communicated in the code? And we have a think about that. And I'll just stop and ask for any questions at this point before I go on to the next section. So I don't see any questions in the Zoom chat. Does anyone else put a question into the Zoom chat if you have a question for me? I don't see anything. there'll probably be more questions as I get further onto the thing, but hopefully this makes sense. So now the question is, that's a nice idea in theory. How do we actually do this in practice, right? That's what everyone wants to know. They don't want just people telling them how to do it. Let's show you how to do it. Okay, so this challenge, if you saw this in a code review, would you accept it, or would you have questions about it? And to be honest, when I was, if a while ago, I would probably be quite happy with this code. I mean, I would write my code like this. But now that I've kind of discovered this way of doing it, I'm not happy with this code anymore. And there's quite a few problems with it. So the first problem that I would see is which things are optional, like this a middle initial. Now, this is a very Americanized contact information. In different countries, obviously, the way you do stuff is very different. Like in Spain, the way you do names is very different from in America. So this is not like an American example, but in America, people have these initials, and they're normally optional. And it's not at all obvious here. You could say, well, I'm going to use a null string if it's optional, but that's not very clear at all. What are the constraints? So, things like strings, they can be like millions of characters long. Can the first name be a million characters long? Can the first name contain unprintable characters, non-printable? Can it have can it have line feeds and tabs and stuff in it? There's almost always some constraint, like the email address has to have an @ in it. It can't just be a plain old string. So there's normally some sort of constraints, and they're not documented. Like here, for example, maybe it needs to go into a database, or it needs to be printed out on a screen. It can't be more than 50 characters long. It's not at all communicated here. Now you could say, well, somewhere else I have some validation code that checks that, and somewhere else I have some code that checks the email address. It has an @ or something in it, but that's not communicated, right? I have to go. It's not at all obvious, and I have to make sure it always goes through the validation logic. And I might bypass the validation logic by mistake. I'm not even aware that the validation logic is there because it's not obvious to me. So this does not represent the design. So yes, this is what people call stringly typed. Yes, I like the word stringly typed. Everything's a string. That's not very good. Now, there's some domain logic here. Yes, there is verified. So this is supposed to be set to true if you have proved that you own that email address. I send you an email and you click the link to prove that you own the email address. So that's meant to be set to be true. And if you change your email address, you have to set it back to false, right? So when you have a new email address that's not verified, you're supposed to set it to false. Well, how am I supposed to know that? That is not at all obvious from this design. And again, you can say, well, I have some special logic somewhere, but I don't know what it is. And that could actually be a security risk, because if you send me a password reset to an unverified email, I might, I could change my email and then get a new password, and that would be a security breach. So, this is quite dangerous. Not only is it bad design, it's quite dangerous. So this code does not communicate important design decisions. So I would say this is bad code. Right, so how are we going to fix it? So let's look at the things. Which are optional? What are the constraints? What's the domain logic? None of that is expressed in this code, okay? However, by the end of this talk, you'll see that I can actually capture all of this stuff. I can make this a much better design and communicate all that stuff in the code without without any documentation, without any special validation logic. So now, before I can do that, I'm going to have to tell you about functional programming. And in particular, I talk about functional programming type systems. And this is why it's functional domain modeling and not object-oriented domain modeling. So in functional programming, the main concept is composition everywhere, composition everywhere. And if you've used Lego, you know what composition is, right? Composition is building bigger things from smaller things. So yeah, someone has a question, can you have behavior inside the types? And the answer is no. And I will ask me that question again, and I'll come, when I take the next break, I'll look at that question. So functional domain, the composition is like Lego. You add things together to make bigger things, right? So this is a big thing made from a bunch of smaller things. So this is a really, really big piece of Lego made from a bunch of smaller pieces of Lego. Now you're not finished here because you could keep adding these and you could connect two of these together to make a really big one. So the thing about Lego is you can always add and add and add and add. It's always a compositional thing. You can just pile things on top and build and build and build. Now, in functional programming, we have the same thing. It's called an algebraic type system, which is a bit of a math word, bit of the mathematics. So I like to call this composable type system. So composable means just like Lego. So just like in Lego, you can take types and combine them together to make bigger types. Okay, so there's two different ways to make bigger types from smaller types in a composable type system, in an algebraic type system. The first way is to use and the second way is to use or. And let me explain what I mean by that. So with and, let's say I want to model like a fruit salad, and a fruit salad is an apple and a banana and a cherry. So how would I model that? Well, I could just use a standard record structure. So in F#, it looks like this. We have an apple field and a banana field and a cherry field. And the apple field has to be a kind of apple, and the banana field has to be a kind of banana. So in F#, we call this a record type. In every language has something like this. It's a struct or just a very simple class. Every language, every programming language has something like this. Okay. And then the field itself has another type, which is all the possible kinds of apples. So it could, just like you might have an int or a string, here I'm saying that if it's an apple, it has to be a kind of one of these apple varieties. Okay. So that's something everyone is familiar with. Anyone who does any programming is familiar with this. Now, the other way, which is much more interesting, is using or. So if I want to model a snack, I might say it's an apple or a banana or a cherry. Right, one of those three things, but only one at a time. Now in F#, we do this. We call this a choice type, and there's a vertical bar for each thing. So this says a snack is an apple or a banana or a cherry. You can think of it as kind of like an enum, if you like, or you can think of it as a class with three subclasses. Not really quite the same, but basically there's three choices, and it can only be one of those at any one time. It can't be all three at the same time. So these are called discriminated unions or sum types, or I like to call them choice types because it's a choice. It's one of these three things. Okay, so this is the kind of thing that's not really available in other languages. Like C# doesn't have this, Java doesn't have it, JavaScript doesn't have it. But you know, Haskell and F# and Elm and functional language has this. Rust has this. Scala has this sort of as well. So why is this useful? So let me show you an example of building a bigger thing from a bunch of smaller things. So let's say you're going to model a payment system and you have cash and PayPal and credit cards. So for cash, we don't need any information. For PayPal, we need an email address. For credit cards, we need a card type, say. Okay. So how would you model this? How would you implement this if I asked you to do this? So I think for most people, if you're an object-oriented programmer, you'd do it in a standard way, which kind of looks like this. You'd start off with some base class or an interface class or something like this, some interface or abstract base class, which represents the payment. And then you'd have three subclasses or three implementations, a cash one for PayPal, and one for credit cards. So I think this is pretty standard for object-oriented design. So I'm going to show you a different way of doing this, which is the composable approach, building bigger things from smaller things. So we're going to start off with small things first. So in a domain-driven design, we don't want to use things like strings and ints. We're going to use words that are meaning something to the domain expert. So people talk about email addresses. They don't talk about strings. They don't talk about strings. They talk about card numbers, right? So it's not the representation, it's the concept in the domain. So the first thing we can do is define some sort of primitive types for our domain, which are going to be the building blocks to build bigger things on. And then we can start using our choices. So we can say, well, a card is either Visa or MasterCard. It's got the vertical bar. And the credit card information is a card type and a card number and, you know, expiration date and whatever, all the other things. So that would be, you know, we've got a choice type there and we've got a record type using and. So we've got an or and an and. Okay, so we're building bigger things from smaller things, and let's keep building on top of that. So let's build the payment method now. So the payment method is a choice when because we say or cash or PayPal or credit card. So that's a choice type, and you use the vertical bar. And in the PayPal case, we have some extra information, which is an email address. And in the credit card case, we have some extra information, which is the credit card information. And the cash case, there is no extra information. Right, so that's a choice type, but we can keep going. We don't have to stop. We can build on top of this. So we can say, let's say we want a payment amount. And then we're not going to use decimals or floats. We're going to use a word specific to the domain. And then say currency is euros or dollars. Okay, so we've got a primitive type and another choice type. And then finally, we can say, well, a payment is an amount and a currency and a payment method. So that is it's a record. It's, you know, one of each of those three things. So this is how we can start off with these small things and build bigger and bigger things by combining them using and combining them using or. So that's the idea of composition. Composition is awesome, building bigger things and smaller things. So let me see. Yes, let me just stop and answer some more questions here. So the types in this only works because the types in functional programming do not have behavior, because it's hard to do an and an or when there's behavior as well. So these are just very simple things. So the behavior is always separate from the data in functional programming. What can we do if we don't have or types in our language, for example, C#? Well, there are ways to work around this. There are tricks to do this in C#, but it's not natural. There are ways you could do the interface thing. It just becomes a bit awkward, but there's another way of using an interface with a bunch of lambdas for each choice. It's just kind of weird. So yeah, in C# they've talked about adding discriminated unions like this, or case classes. In Scala they're called case classes. Kotlin and Scala, they have them. But yeah, you're gonna have to wait a while before you get them. Sorry. But these kind of discriminated unions or choice types are really, really useful for domain modeling. So I really think every language should have them. So yeah, there's nothing quite like this in object-oriented programming. The only thing you have in object-oriented programming which is nearest is inheritance. But the difference between this and inheritance is that this, when I talk about cash, PayPal, and credit card, there's three choices, and I'm fixed. This is fixed choices. With inheritance, I can have any number of implementations, and so you know, sometimes that's what you want. Sometimes you want an unlimited number of implementations, but sometimes you want a strict fixed choice. Like if I add a new kind of payment method like Bitcoin or something, you know, I don't want to just be able to add it. I want that to break the rest of my code because I'm not handling it. So in this way, when you add a fourth choice, all the code, all the switch statements that have three choices in them will then complain that you're not handling the fourth choice, because it knows exactly that there's only four choices or only three choices. And that's a really valuable technique. It's what you might, it's a closed list of choices. It's not an open list of choices. Would it be appropriate to treat currency as a unit of measure? Yeah, you could. There's lots of different ways of doing this. I just picked the easiest one. There are, in F# you have this thing called unit of measure, which you can attach to numbers. Yeah, it's just one way. There's a couple of different ways of modeling. I prefer this way. I think it's simpler, but units of measure is fine. Yeah, you can do with inner classes. Yeah. So how you want to implement this in C#, if you Google how to implement discriminated unions in C#, you'll find a bunch of different ways of doing it. But normally they do like an internal hierarchy, but these are private classes and you can't see them from outside. Yeah, there's a project called Luthi, L-O-U-T-H, I think. Let me just see if I can. There's a project called Luthi. I think it's Luthi. Yeah, there you go. Thank you. Somebody posted it. So check that out if you're interested. Personally, in C#, I wouldn't actually use it because the problem is that in order to use it, you have to understand what's going on. And so if you're a normal C# programmer and you're not used to functional programming, these things won't make any sense to you. So if you do understand what's going on, then fine. But I mean, it makes it very hard for other C# people to maintain the code because they don't understand, that knowledge. And if you do understand all this stuff, then I would switch to using F#. If you understand functional programming really well, I would switch to F# anyway and just use F# because it's a lot easier. So I'm not a fan of C# adding all these features because it just makes it more and more complicated. There's now lots and lots of different ways of doing things in C#. I like my languages to do one thing well. So C# is a really good object-oriented language. And I think, by adding all these features, now they have to support, there's 5 different ways of doing async and 3 different ways of doing, other nested classes and inheritance. And it's like, it just gets more and more complicated the more features they add. So I personally would stick with what C# is good at. And if you want to use functional programming, use a different language. So that's my opinion. Right. Okay. Let's see. So let's move on to the next bit, which is domain modeling. So we've got these composable types and what can we do with them? Okay. So let's take that contact challenge that I had and let's see if we can solve it using this composable types. So here's what we had. This is what we started off with. And to be honest, this looks very much like database-driven design. This looks like there's a table in the database which has 5 columns in it. And we've just made our domain model look just like the database table, which is fine if you're doing database-driven design, but we're not. We're doing domain-driven design. So let's not do that. Let's refactor this to make it much more domain-driven. Okay, now, when I'm talking, one thing is to pay attention to how people use the words. When I'm talking, I would say that a contact has a name and an email address. I don't normally say a contact has a first name and a middle initial and a last name and an email address and a flag. That's not how I'd normally say it. I would say a contact has a name and an email address. So let's model it that way. Okay, it has a name and an email address. Now, those 2 things are now new concepts, right? So we have a new concept called a personal name and a new concept called email contact information. So that's actually better already. We have these concepts are not fake concepts. These are actually really important concepts that we would use in terms of a shared language, right? It might be that as soon as you start using a concept of a personal name, there's now rules about personal names, like, data protection or whatever. So this is good. We've already made the domain better. Okay. So what's a personal name? So now we have a personal name has these 3 fields. And at this point, we now to say what's required and what's optional. Let's start with that. So we want to say that the first name is required, but the middle initial is optional. And as I said before, this is not at all obvious from the design. How can we make it obvious in the code? How can we represent optional values? Well, one thing you can say, well, I'm going to use a null, but that's not very good because it doesn't actually represent, it's not very clear, what it is, right? The fact that it might be null, it might not be null. I can't tell from looking at this. So what we're going to do is create a type called option, which is a choice. It's either something or it's nothing. It's got some data or there's no data. So it's either missing or it's present. Now, the nice thing about this is a type that is we can create ourselves because it's a choice type. Now, normally it's built in. Most functional languages have this built in. But if it wasn't built in, we could easily create it because, like I say, it's just a choice type. And so this is where choice types are great. You can model missing data, something or nothing. And notice we're using the word or, something or nothing. So it's a choice between 2 things. So these are really useful. And in F#, we'd make it a generic type like this. In F#, the little tick T means it's generic. In C#, we wouldn't need the little tick in front of it. But this is how you document, how you design it in F#. And like I say, it's a built-in type. And once we've done that in F#, we can then say, well, okay, this one is optional and the other ones are required. So the rule in general is if it's not optional, it has to be required. That's basically the rule. We never use nulls. Okay. And the other nice thing about an F# in particular is you can take the option and you can put it afterwards. So rather than saying option of string, you can say string option. That's just a little bit readable for people who are not programmers. It makes it a little more readable, I think. All right. Now, what about these simple values? So I stressed before, we really want to avoid this thing called primitive obsession. So every time you use a word like an int or a string or a float, those are programmer concepts. Those are not concepts that make any sense to anybody else who isn't a programmer. I remember I was talking about floats, and somebody said, does it have something to do with water? And fair enough, that's a good question. Why am I talking about things which are floating? Floating point. It's not floating on water. So we really should stay away from words like this when we're trying to do domain modeling, because anyone who's not a programmer will not know what you're talking about, and it's very confusing. So don't use words like int or string or float. Now, another thing which is common is that it's really unusual to have a completely unconstrained type. Like an int, how often do your ints go up to 2 billion or 4 billion, right? It's pretty unusual. How often are your strings like 1 million characters long? I don't know what a maximum length of a string is, but it's pretty big. It's really unusual to have a string which would be 1 million characters long. So we should document the fact that they're constrained somehow. So for example, an email address, it's got a lot of constraints. It can't be an empty string, and it has to have an @ in it, right? A phone number can't be an empty string, and it has to have some pattern. Maybe it has to contain digits or something. Whatever the rules are, but it's what it is not. It's not just a bunch of random characters. There's always some rules. Even something like a customer ID, a database ID, it normally has to be a positive number, right? So, don't model these things as primitives. So an email address is not a string, and a customer ID is not an integer. And another way you can tell is if an email address was just a string, then you could take two email addresses and concatenate them together to make a bigger email address. Well, that's not true. I mean, it works for strings. Two strings added together is a bigger string. Two email addresses added together is not a bigger email address. That doesn't make sense. A customer ID, it's not an integer. Like, can you multiply it by 42? Can you take the square root of a customer ID? That doesn't make sense. So it might be represented by an integer, but it's not an integer. You can't do mathematics on an integer, on a customer ID. So what we're going to do in domain modeling is keep the representation separate from the code. So we're going to use a wrapper type. So in this case, like an email address, it's not just going to be a plain old string. It's going to be a wrapper around a string. And a customer ID is not just going to be an integer. It's going to be a wrapper around an integer. Okay. So we have these wrapper things. This is how it looks like in F#. In different languages, it would look different. In C#, it would be basically a class with one field, called value or something. So there's lots of different ways of doing it. This is the F# way of doing it. And then even something like a 50-character string, that's just not a normal string. So we're going to make a wrapper around that to represent this is a 50-character string. Okay, that's a constrained string. So we have these wrapper types. And one of the things, as soon as you do this, an email address is a wrapper around a string, and a phone number is a wrapper around a string. And as soon as you do this, it becomes distinct types. So they are different types. They cannot get mixed up. If you try and mix them up, you will get a compiler error, a compile time, not at runtime. And if you have a customer ID and an order ID and you use wrapper types, they become distinct. They're no longer the same type. So you can't accidentally pass them as a parameter to the wrong thing. So this is really good. So first of all, it's clearer domain modeling. Doing this is good because it makes the domain model much clearer, and it also stops bugs because you can't mix them up. For example, you're trying to compare an order ID and a customer ID, comparing whether they're equal. That is a compile error. That's not a bug. I mean, you shouldn't be comparing these things. They've got nothing to do with each other. So if you try to compare these things, that should be a compile error. Right. So the first thing people say is, okay, so I've got these constrained types. How do I actually construct one of these things? So let's look at the email address example. Let's say I want to create an email address and I'll pass in a string. Now, if it has an @ sign, then I'm going to wrap the string in an email address. But what happens if it doesn't have an @ sign in it? What should I do? Should I return a null? No. Should I throw an exception? No. So what we're going to do, if you look at the signature, if you say, as it stands, it says, you give me a string and I'll give you back an email address. And that's wrong, because if you give me a string, I might not be able to give you back an email address. That's a lie. Okay. This is a bad signature. We don't want to have signatures like this. So instead, we'll do this. We'll say, if it contains an @ sign, I'll wrap up the string and I'll give it back as an option, something, and otherwise it's nothing. And if you look at the signature, this says, you give me a string and I might give you back an email address. Maybe, if you give me the right kind of string. And if you give me the wrong kind of string, I'll give you back nothing. So this is a much nicer way. This is not a lie. It's much more explicit. It's much more self-documenting. And it means that you don't have any kind of, you don't have to worry about exceptions or nulls or anything weird. So we try to, in functional programming, we try to write all our code that looks like this. Let's do the same for string 50. So again, if the string is smaller than 50 characters, that's good. We'll give you back something. And if it's not smaller then it's a bad string. You gave me a bad string. And I can just tell looking at the signatures, like you give me a string and I might give you back a string 50, depending. So I can tell straight away that it might not work. And so I have to handle that, but it's better to handle it and know that I have to handle it than forget to handle it and have an exception or a runtime error or something. Here's another example based on something I actually saw once, where you have an e-commerce site or like an Amazon type thing, and there's like a million things in your shopping basket or your shopping cart. And that's a bug, probably because the person implementing it used the integer to represent the number of things. Well, almost certainly you can't buy a million things on Amazon. You probably can only buy like 100 things at a time, right? So this is the problem. They used an integer because they were lazy. Okay. So what we're going to do is create a whole special type called an order line quantity, which wraps an integer. Okay. We're going to create a whole new wrapper type just for this one specific domain. And most people don't bother to do this because people are lazy. And to be honest, I'm lazy. I wouldn't be bothered to do this in most languages, but in F#, it's a one line of code. So, I think the language you're using makes it a lot easier to do this kind of thing sometimes. So I have this special constraint type now. It's no longer just a regular integer. Again, I can't take the square root of an order line quantity. I wouldn't multiply it by random numbers. Typically with an order line quantity, you add 1 to it or you take away 1, right? You don't really do a lot of arithmetic on it. So how do we create one of these things? Well, if the input is bigger than 0 and less than 99, then that's good. I'll give you back something. Otherwise, you give you back nothing. And if I look at the signature, it says, you give me an integer and I might give you back an order line quantity if the integer is good. Now notice that 0 is not valid. So if you give me 0, I'm going to give you back nothing. And which means that you can't have a certain bug. Like if you have one of this order line quantity and you have like a minus button and you say, I start off with 2 and I should take away 1, I have 1, and I take away 1, I have 0. You can't have 0. So as a developer, you are forced to deal with a case when it goes to 0 because you don't have one of these things anymore. So you have to say, well, what am I going to do? Am I going to remove it from the carts? Am I going to leave it at 1 and not go down to 0? I don't know what the right answer is, but what you can't do is have a bug where you forget to handle it. That's not even possible because you literally cannot have a situation where there's 0 items, and you can't have a situation where there's negative items. Like if you were using an integer to model this, you could accidentally have -1 items, right? And that would be a bug. And you say, well, I'll write a unit test so we don't have that bug. Well, that's a unit test. If you do it this way, you don't need to write the unit test because it literally cannot happen. So this kind of way of doing things actually helps you to get rid of a lot of your unit tests because the things that you have to test for literally cannot happen in this model. Yes. As someone's saying in the questions, there's something called value objects, which is exactly the same thing. Yes, it's the same concept. Right, so let's look at the code that we have after our first refactoring. And this is what we had at the beginning. Now we added optional types, and we've now added these constraint types, and that's much better. And we've added these two different domain concepts that we didn't have before. So this is in domain-driven design. These correspond really well to what's called aggregates or consistency boundaries. Like, you know, these things can be updated independently. Like one person can update the name and the other person can update the email at the same time. And that's not a concurrency error. But if two people try and update the name at the same time, that is an error. So the domain-driven design people have a concept for this called aggregates. And this is also nicely captured in this design. Okay, so there's one final thing that we've forgotten about, which is this verified flag here. What are we going to do about this? Actually, before I go on to this bit, let me just ask any more questions before I move on to the next bit, because we've got another 50. So that one of the questions was, is adding refined types to the domain useful? So do you mean, I guess what you mean by refined types is things like string 50 and email address? I think that's a concept from other languages. Yes. So yes, I think it's super useful because things like email address is a concept in the domain. It's not just a thing that you do for the sake of doing it. It's actually a concept in the domain that domain experts would use. Now, things like string 50 is not really a domain concept. So to be honest, maybe I shouldn't use the word string 50. Maybe I should just use the word name or something. Sometimes, or maybe I wouldn't bother. Maybe it's not worth it. There's a balance between going overboard, but trying to be too clever and making stuff which is sensible for the domain expert to understand. And so I think email address is important. I think order line quantity, that's a domain concept. Payment amount, that's a domain concept. String 50, yeah, I don't know. So it depends. Let's see. Yeah. So yeah, again, value objects, exactly the same kind of thing as these constraint types. Are using very simple types without any behavior. They all do, but they basically wrap data in a way that constrains them to be always valid. Are types and function definitions equivalent to interfaces and implementations? Yeah, a function is basically an interface with one method. So a function type, or rather a function type, when I say to deal, and I say the input is a deck of cards and the output is a new deck of cards, whatever. I don't tell you what the implementation of to dealing is. I just say this is the input and the output, or to shuffle, the input is a normal deck and the output is a shuffle deck. I'm not telling you what the implementation is. So you could think of those function types as an interface with one method. So yeah, totally. So the type, yeah, a type is not really like a class. It's really just the set of values. A type is just the set of inputs and outputs for a function. It's not more complicated than that. Do you find that unwrapping the types to work with them causes a lot of overhead? Yeah. So this is the thing. It's like every time you want to use these things, you have to unwrap them and wrap them back up again. The first thing is, it turns out that you don't normally need to unwrap them and wrap them very often. This logic about validating, like creating the email address and dealing with optional values and stuff, this typically happens at the edges of your code, not in the middle. Typically, your code comes in as strings, as JSON or something, and you have to validate it, make sure it's good. But once it's valid, these things are immutable. So once you have a valid email address, you never have to do any defensive programming. It can't ever be null. It can't ever change. It can't ever not be a valid email address because it's immutable. Once you've got one, it's always good. So a lot of the defensive programming goes away in this style of programming. Like I say, you have validation at the edges of your application, but in the middle of your application, you never need to do any validation ever again. Now, in terms of unwrapping and wrapping, this is where things like a lot of the functional terminology like monads and all this stuff comes in, because there's ways of doing this without having to explicitly wrap and unwrap all the time. There's ways of kind of working with these things without having to do that. And I haven't got time to go into in this talk, but I do have other talks on functional programming patterns and so on. But yeah, there's patterns for dealing with this without making it so ugly. It actually looks very, very nice. when you do it properly. But yeah, I unfortunately I don't have time to show you. But yeah. Right. Okay. Let's move on. So replacing flags with choices. So the one thing we haven't talked about yet is this email verified Boolean here. Now, Booleans are always a bit of a code smell, in my opinion, because you never really know when are they supposed to be true, when are they supposed to be false. It's just not very clear. And you can say, well, go and look in the documentation, but I don't want to look in the documentation. I want to have it in the design right in my face. So how can I fix this? Okay. Now, it turns out there's some business rules that go along with this Boolean. And like the first rule is that if you change the email, you have to set it back to false. Like it's not verified because you just changed the email. And the second rule is that because this is a very important field, we only want it to be set when the email is known to be verified, when it's gone through a verification service and we've checked that it is actually a verified email. So these are two really important rules. And as it stands, we don't know whether it passes these rules or not because it's just a Boolean. And even if we did have some code somewhere else that did it, it wouldn't be obvious. You know, I could forget to use that other code, right? What I want to do is make sure that these rules are always followed, no matter what, no matter how bad people are, they always follow these rules. Okay, so right now it's a security risk because anybody can set this to be true. So let's fix it. So if we listen to what the domain expert says, right, they say an email address is either verified or unverified. Okay, so there's the word or. Okay, so we're going to model it as a choice. It's either unverified, or it's verified. Now, if it's unverified, that's just a regular old, we can just use any old email address. We don't care about, you know, anybody can set it to be unverified. There's no security risk setting it to be unverified. Okay, but then I say, okay, so what data do we need if it's verified? Okay, so in the first one, we don't care what it is, but in the second one, we have this special thing. So what do we put here? So I go and talk to domain experts, and they say, you know, I asked the domain expert, is a verified email the same as I don't know if you're seeing, I'm getting a block here. Is a verified email the same as an unverified email? And a domain expert would say, well, no, they're different because they have different rules. Like verified emails, you can do stuff, but unverified emails, you can't. And they say, no, there's different business rules. You mustn't mix them up. So just like when we talked about a shuffle deck and a normal deck of cards, it's the same thing. You mustn't mix them up. So I'm going to model them as two different things. And the way I'm going to do that is create a wrapper around an email address, right? So I'm creating a wrapper around a normal email address and I'm calling a verified email. And as soon as I create a wrapper like this, it's now a different thing. So I'm now saying a verified email is not the same thing as a normal email. So that's good. Okay. And I like to say there's no problem that can't be solved by wrapping it in another type. I've already got a wrapper around a wrapper around a wrapper, but you know, that's fine. And people ask me about performance and efficiency, and I'll answer that in a minute. I'm sure people always will say that, but okay. So now we say in the verified case, it's a verified email. Okay. So the only way I can do a verified thing is if I have a verified email. All right, now, where do I get these verified email things from? And I get it from the special verification service, right? So let's model that. We're going to say the verification service has an input and an output, and the input is an email address and some sort of hash, right? So you give me an email address, and I might give you back a verified email. Now, it might not work because the hash or whatever it is might not match up with the email address, or it might have expired or whatever. For various reasons, it might not work anymore. So it might not always work. So it's very, very clear from this service that the verification process might fail. Again, rather than throwing an exception or returning a null or something, it's very clear from this. This is a self-documenting design. Okay, so now if we look at what we've got this verified email, which is a wrapper, and we have this verification service, and we have this choice between unverified and verified. So let's look at the business rules that we said. The business rules said that if you have a normal email address, you can only create the unverified case. Like if you change it to a normal to an unverified email, you have to use the unverified case. Well, that's true, because the only way I can create this choice with a regular email address is if I use the unverified case. All right, now, if I want to create the verified case, in order to create that case, I have to have a verified email object. Okay, where do I get a verified email object from? The only way I can get a verified email object is from the verification service. And so I've this business rule that you can only create verified things when it's been gone through the verification service. We've got this business rule. It's been guaranteed by the design. I don't have to have any special logic anywhere, any verification logic, any documentation. I literally cannot write bad code because the design won't let me. Now, people might say, what happens if I go through a backdoor and I don't, use the verification service? Well, what you do is you do the same thing you do with object-oriented, which is you have a private constructor, and you make sure that this private constructor is not accessible to anybody. And so the only way you can create it, you can think of this verification service as sort of a factoring method, where it's the only way you can get one of these verified emails is using this factoring method, which is the verification service. And you make it a private constructor so nobody else can create one. So just like you would in OO. But that's really nice because we have now self-documenting code, and you literally cannot do the bad thing. I don't have to, like I say, I don't have to look in documentation. This is much easier to get right. Okay, so let's look at the challenge. This is now what we have, which we have an email address and a verified email and an email contact, which is a choice. And we have a personal name and we have a contact. And we have a lot more things now than we started with, right? So all these questions we had at the beginning, which values were optional, what are the constraints, what's the domain logic? These are now in the design. They're not in documentation. They're not in some validation code somewhere. We can literally see, we have this email address thing, we have a string 50, all these things are now constrained, much more obvious. And which fields are linked, that's much more obvious. And the domain logic about verification and unverification, that is much more obvious too. So all this logic that we had like in our heads is now in the code. And we don't have to have, like I say, we don't have to have documentation to explain it. Now, some people say, well, we started off with one type or one class, and now we have 6 or 7. We have a whole bunch of new things that we didn't have before. Is it more complicated? And I'd say, no, it's not more complicated. It actually represents the domain better, because everything we're talking about is actually words that people use when they're talking about the domain, right? This domain language, this shared language that we're using, these are important parts of the shared language. A concept like verified email and email address and personal name, these are important concepts in the domain. So we're not making it more complicated for no reason. We're actually trying to capture the same words that the experts would use when they're talking about it. And again, of course, this is compilable code. This is not a UML diagram. This is code. Now, one thing which is really important in domain-driven design is this concept of refactoring towards deeper insight. And what that means is when you learn something new and you start doing some refactoring like this, sometimes that new thing you learn can actually have repercussions, and you find that's really useful in all sorts of areas that you didn't even think about when you started. So if we talk about our verified email, let's look at an example. Let's say that we have in a completely different part of the program, we have a business rule that says you can only send password resets to people who have verified emails, who've proved that they own the email, right? That's a very sensible business rule. Now, before we did this refactoring, we would have something like this. You give me an email address and I have to check and see if it's verified, and only then can I send the password. And if it's not verified, I'll say an error. This should never happen because you should never be calling me with this thing. And there's some, there's a bit of logic here, and it's quite easy for me to forget to use this logic and have a security bug, or I bypass it by mistake, because it's very easy to make mistakes in this kind of logic. Now, after we've done the refactoring, and by the way, if every time you see this should never happen, that's a bug waiting to happen, because it's one of these days it will happen. So how can we get rid of this should never happen? Well, as soon as we have this concept called a verified email, this is a new concept that we didn't have before. We can change our password reset and says, you know, you need to give me a verified email. Okay, you give me a verified email and I'll send you a password reset. Now I don't have to do any validation. I don't have to check, is it verified or not? You literally can't get this logic wrong because you have to send me you have to pass in as an input, you have to pass in a verified email. So once you change one part of the design, you start finding all sorts of other parts of the design that get better as a result. So I think this is very, very cool. This is the idea of why, you know, this kind of design is very, very useful. Right, I've got a little bit more to go, but I'm going to stop and answer any more questions. Let's say, yes, there's a paper by Bill Cook which is a very famous paper on FP and OO. Are there any open source projects or commercial examples which use functional domain-driven design, preferably with F#? Yes. There is, first of all, there's the Git repository that goes along with my book, which is open source. I can post a link to that later on if you like. If you just ask on Twitter, if you use the F# hashtag, you'll probably get lots of answers. There's a whole book called the Elmish book, which is a front end, doing front end stuff with F#, but that's also domain-driven design. The thing about domain-driven design is it's not an example. I guess the thing is you don't want to copy other people's examples because, as I said, the idea is not to, it's not about the actual code. It's about the process of getting everyone on the same page. So if you just copy my code, you haven't actually learned the concepts. So the domain-driven design idea is that, you know, you communicate with the domain experts and you have a conversation with them, and together you document the domain using the words that everyone understands, and then you represent that in the code. So, you know, I'm wary. That's why, and this is not just true for functional, but this is why there's not a lot of object-oriented domain-driven designs either, because it's not really about the code, it's about the process of building the code. So yes, you can look at my examples, you can look at other people's examples, but that just tells you how to write these kinds of types, but it doesn't tell you about the whole domain-driven design process. So what I would suggest to do instead is pick a domain that you're an expert in, pretend that you're the domain expert, and try and document it yourself in this way. Like if you're an expert in you know, collecting you know, Dungeons and Dragons, or you know, collecting whiskey or knitting or cycling or something, find something that you're an expert in and try and document everything using this approach. And that's the best way to learn, I think, rather than just kind of copying somebody else's code. Right, any more questions? I think that's all good. Okay, so I'm just going to finish up. Oh, what about exceptions? Yes. So notice that I'm not using exceptions anywhere because in my design, if I go back to the thing about the verification service, where is it? Here we are. This one, yeah. This verification service, it says you might give me back an email. Go back to this one here. I don't have to have an exception. The problem with the exception is it's not self-documenting. I don't know. I have to look at the code. I have to either look inside the code or I have to look at the comments in the code to find out what the exceptions are, unless you're using checked exceptions in Java or something. But, you know, in C# we don't do that. So rather than doing that, I'd rather explicitly say this might not work and you have to deal with it. And I guarantee that you're going to have to handle the case when it doesn't work. So it's much better than using exceptions, I think, much more documenting. Now, sometimes you want to have more detail. An option just says it either worked or it didn't work. If you want to actually have an error message in the false case, like it either works or it didn't work, and here's a nice error message for you to deal with, instead of using an option, we'd use something called a result. So a result is another choice type. It's either something, just like something or nothing, it's either success or failure. And in the failure case, you can have some extra information about why it went wrong. So if you're interested in that, I have a whole thing called railway-oriented programming, and that's all about error handling in functional way. Let's see. Okay, so where did we go? I'm sure someone can link to the ROP talk. Right. Yeah, I'll just type this in Google. Exceptions. Right. Okay. So the final bit here then is we've done a lot, and let me show you. You can keep going as the domain evolves. You can keep doing this kind of thing even as you change it, because things never stay static. So this is not big design up front. This is a living design that changes as you learn new things. You want to maintain that in your code. So let's say that sometime, a few months later, they have a new requirement, and you have to have an address as well as an email, a postal address as well as an email. Okay, and we have a new business rule that you have to have an email or a postal address. Okay, it sounds sensible. Now, if I look at this code, it does not meet the requirements because, as I said, that everything is required unless you say it's optional. So as it stands, these are both required fields, and that's not what the business rule said. Okay, so this is wrong. So I say, okay, I'll make them both optional. But that doesn't work either because they could both be missing. Now, you could say, well, okay, if they're both missing, I'll have some validation code that checks if they're both missing and throws an exception if they're both missing. And you know me, I'm going to say, no, don't do that. Let's try and model it in the design so you can't get it wrong. Okay, so this is not going to meet the requirements either. So there's a really nice phrase here, which is make illegal states unrepresentable. That means rather than letting bad things happen and then trying to validate them, you literally cannot have a bad thing happen. You cannot write code for the bad thing. You cannot even write it. And if you can't even write it, it can never happen. You don't have to test for it. You don't have to write unit tests. It literally cannot happen. So how can we do that in this situation? Well, if you think about the business rule, when you say you have to have an email address or a postal address, right? Well, it means you have an email address or a postal address or both, right? So that's when we talk about it, that's how we would say it. So there's three choices only, not four, just three. And we're using the word or. So that really tells you how we're going to model it. We're going to model it as three choices, right? So we'd say it's email only or address only or both. And in the both case, we have a pair. So that's how we would model this. And we literally, the fourth choice where they're both missing is not even a choice. So I literally cannot have them both be missing. I can't even write the code where they're both missing. And what's really nice about this is that this is self-documenting code again. If I'm a new developer and I come onto the team, I can immediately see what the various choices are. I don't have to ask somebody. I don't have to look at the documentation. It's like it's staring me in the face what the choices are. So that's very nice. There's only three possibilities. You cannot make a mistake. So that's nice. This is the kind of thing which is very cool. We're kind of encoded, the business rules are actually in the type system. So this is why people love types. Composable types are almost as awesome as a cat on a unicorn. Yeah, not quite as awesome as that, but pretty cool. Now, you might be thinking that's actually a pretty ugly design, and I agree. And so this is where this pushback from developers, why everyone it should be involved. It shouldn't just be developers being told. Developers can contribute to the conversation as well. And as a developer, I would probably say, you know, this is a kind of ugly design and it's kind of weird rule. Is it really what you want? It's kind of rigid. You know, if I add a new kind of way of being contacted, it gets more and more different combinations and it gets messy. So I can say, what about this? How about a contact has to have one way of being contacted? It is almost the same thing, but it's a lot easier to implement. And the business will probably say, sure, that's fine. That's, you know, we don't care. So this is a much better design. And what's nice about it is we can then model it like this. Here's two different ways of being contacted. It's a choice, either email or address, right? So there you got two choices for being contacted. And then in the main code, we say, well, you have a primary way and a secondary way, and the primary way is required and the secondary way is optional. So this is a much easier model to understand. It's not exactly the same because they could both be emails or they could both be addresses, right? So it's not exactly the same logic, but I think for most practical purposes, it's much more useful. And what's nice about this is you can evolve, you can add Facebook, you can add texting, you can add Twitter, you can add Skype, you can add all these things to these choices, and it gets longer and longer, and the design doesn't get any more complicated as a result. So this is a much nicer design. So it's not just a one-way thing. I think say it's a conversation development. It's conversation-driven development, not top-down development. So to summarize, and then I'll do some questions after that. We're going to try and represent the shared mental model in code, very important. And you want to become a domain expert. You don't want to just, write code that doesn't represent the domain. And it's a collaborative process. And designs will evolve, and you want to capture, as the design changes, you want to keep capturing those changes in your code, right? This is not big design up front. And every time you do a refactor, every time you learn something, you refactor the code, and every time you refactor, you might actually find some really useful thing, just like when we learned about verified email addresses. We start, oh, here's another place we can use them. They're useful in all sorts of places that we didn't even think about when we started out. And one of the nice things about using static types, is that you can, if you make a change like this, you get a whole bunch of compiler errors and you just have to fix them all. But once you fix them all, you're pretty confident your code works. So one of the problems with using JavaScript or Python or something is that you don't have that kind of confidence. So when you make big changes like this, you have to do a lot of unit testing just to give you the confidence back. With static types, you have a lot more confidence that changes haven't broken anything. Composable type systems are fantastic. Using choices are fantastic. Using options is great. Using these wrapper types is great. These are all really good things because they let you make illegal states unrepresentable. So that's it for the main part of the talk, and then I'll answer questions in a minute. You can see this talk on my website /DDD. And if you're more interested in this, I have a whole bunch of trainings coming up. I'll post these on the chat if anyone's interested. And of course, I have my book, which people seem to like, which is basically this whole idea, but a lot more in depth. So, okay, I will ask any more questions. I know we've probably passed our time limit here. I don't know when we're supposed to end, but I'm happy to stay here and answer questions for as long as people want to. It seems like quite a few people are still in the meeting. That's good. Any more questions? Yes, okay. Are companies considering the benefits of domain-driven functional programming? It's hard to find people to program like this. Yeah, I think it's still kind of new. There aren't too many people promoting it. I think it's fantastic, and people who've used it seem to think it's really good. What can I say? Hopefully that becomes more popular. Yeah, it's not. I mean, I think it's really obvious how good it is, but what can I say? People are very slow to change. That's, I wish people would change faster, because I think this is nothing to do with what I like about this. It's not like a technical thing. It's not like using monads or using weird functional programming things. It's really just modeling things in a really obvious way. So I think there's a lot of benefit to it. Yeah. Question to the audience. Yes. Is anyone using domain-driven design in their job? Yes. So a few people are. How do you enforce the primary content information is not the same as you can't? Yeah. So yeah, actually, that's a very good question. One of the people, sometimes if I go back to this, and go back to the slide here, which is this one here. So yeah, the question is here, how can I make sure these are the primary and the secondary one are different? And the answer is you can't easily. And you can't solve all the problems with this approach. I mean, another good one is like in that card game, can you represent the rules of the game? Can you represent the rules of poker, for example, in that domain model? And the answer is no, you can't really. So what you can do is capture the concepts and the ideas and the building blocks, but the detailed rules of the business logic, almost always you can't really capture it very well. So in a card game, you can't capture the rules of the game. In something like this, capturing that they are not the same type, the same address, that's going to be really hard to do. And there's always going to be in a business, there's going to be all sorts of rules, like rules about how if you're pricing products, or if you have permissions for security permissions and stuff. These are not really rules that you can represent in the type system. They're something you have to just do that in regular code. But the concepts can be represented in this way. But yeah, so that you can't fix everything this way, unfortunately. You just do the best you can, really. Let's see. Is it a good idea to implement the repository pattern when using domain-driven design in functional programming? No, because the repository pattern is really an object-oriented pattern. I actually have a talk called Reinventing the Transaction Script. And if you Google that, I talk about exactly that. And typically in a functional program, anything which can change, anything which is unpredictable, you always keep on the edges of your program. And so that includes anything to do with databases, anything to do with networks, all that stuff, you keep it on the edge. And so the middle part of your program is always completely predictable, completely pure, right? And makes it really, really easy to test. So the database side doesn't become, basically you load stuff up from the database and you do your business logic and then you put stuff back in the database. So having a repository pattern doesn't really make sense, because how you load the stuff up in the database, you can just use regular SQL statements, or you can use, Dapper, or you can use Entity Framework or whatever. It doesn't really matter how you do it, because that's not the database is not part of your business logic. It's not database driven design. So the database is not part of the core logic at all. I wonder if I can actually quickly show you that. I wonder if I have a quick picture. Yeah, let's see. Yeah, there we go. So this is a typical functional architecture. You have the outside world. You do some I/O where you load stuff up from the database. And the nice thing about this is the unit test is just the stuff in the middle, which is completely predictable. And anything to do with integration test is the whole thing from beginning to end. So you don't really have objects, you just have workflows. Notice this whole thing is one big function with an input and output. It's not a bunch of services that talk to each other. It's just like an input and output, and you validate the input, you load stuff from the database, and then you do your business logic. And do I have another? Here we go. There's a better example here. So you load some data, you process it, and you save it out. So like I say, the repository pattern doesn't really make sense in a functional design like this. Let's see, what else? Transitioning database-driven design to, I guess this is what you're trying to do. Warehouse management system, awesome. Yes, C# developers trying to apply domain-driven design should move to F#. I think some of this stuff is easier in F#, yes. Let's see. Trying to use an ORM. Yeah, so like I say, the whole point of an ORM, like entity framework, is that your domain model is the same model that you use in the database, and you just transfer between the code in memory and the code on the thing. And to me, that doesn't make sense, because the domain models I have are a lot more complicated than that. As you can see, that the domain model I had here, which is this one, where is it? I mean, this is a really hard domain model. With you've got choice types, you've got 3 or 4 different things. You've got some of them are choices, some of them are records. It gets really, really complicated. And this email content is a choice between verified and unverified. It's really hard to just map that straight to a database because this is not database-driven design. So yeah, mapping it to a database can be complicated, but it's not part of the domain model. It is tricky. I'm not saying it's not tricky, but it's not part of the domain model. With something like Entity Framework, it really encourages you to have the same code in your domain as in your database. And so it really encourages database-driven design, So that's why I don't like that. In the case of the shuffle deck, in the use case, we pass a function to connection to the database. Yeah, so in this use case, the IO part would know, yes, that would be the bit which knows how to talk to the database. So you take your core business logic in the middle and you compose it with a database function at the beginning and a database function at the end, and you connect them together like Lego into one big function, and that's your entire workflow. So I hope that answers that question. Let me see if I can find my reinventing the transaction scripts thing for you in a second. Oops, there we go. Yeah, there we go. Let's see. There was another question here. In the case of the shuffle deck, I don't see where I could write the implementation of how the deck is shuffled. Right. So let me actually, if you've got time, I can actually write some code for you here. So if I go to I'm in Visual Studio here. So I have a deck equals a deck of card list and shuffle deck is a shuffle deck of a list of cards. And for the cards, I'm just going to say it's a string for now because it doesn't really matter what it is. So, and then I have my shuffle function. It takes as input a deck, and it takes as output a shuffle deck. So that's my domain. And then on my implementation, open the card game domain, and I would say let shuffle. And this is a function that takes in a deck. Whoops. And it spits out. I have to shuffle the deck somehow. So if I do this, if I just return the original deck, I actually get an error saying I'm supposed to have a shuffle deck, and I just give them back a normal deck. So I'd actually implement, this is the implementation here. And this is kind of the interface, as it were. But the point is, I don't care about the implementation when I'm doing my domain model. I don't care about the implementation at all. When I actually write the code, obviously the real implementation does get messy. So yeah, you could think of this as an interface with one method. I mean, you could call it iShuffle, and that's like it's not an interface. It's just a function that implements that interface. So I hope that makes sense. What else do we have here? Yeah, I'm struggling a lot with task, async, await in C# and functional programming style. Yeah, so again, if I go back to this model, anything to do with async, every time you have async, it implies that you're dealing with things which are unpredictable because there's a time delay, right? So anything to do with I/O, hitting a database or reading from a file or reading from the network, that's going to be async. So there's going to be async at the beginning, at the end of these things, but hopefully in the middle, there's nothing async because it's just pure business logic. So try and write the business logic without the async, and then you have to like fit it into the async pipeline. And again, I have a talk about that, which is called the FP Toolkit. Let's see if I can find it. I have lots of talks about these things. Where is it? There it is. Right. What else? I disagree about EF core being bad for domain-driven design. Yeah, it's borrowed from Hibernate. It does. Yeah, I think you can do a lot of this stuff now. I haven't used Entity Framework. The last time I used it was like 5-6 years ago. So I think it's a lot better than it used to be. But I think the thing about Entity Framework is designed to be able to load and save data in the middle of workflows. And if you're not doing that, it doesn't have that much benefit. If you're just loading all the data up at the beginning and saving all the data at the end, I personally prefer using Dapper just because it's easier. But yeah, you could use you could totally use Entity Framework. I don't mind either way. I'm not saying it's a bad thing. I just think that the traditional use in an object-oriented model is that you're mixing in an object-oriented world, you often mix input and output with your workflow. They all kind of tangle together. And in a functional workflow, you tend to keep them at the edges. And so a database framework is not as important in a functional model because you're not really doing any database stuff in your business logic. So what else do we have here? Yeah, you can. I mean, you could try it. People have had a lot of people have painful stuff with Entity Framework. But yeah, if you know what you're doing, I mean, I'm not pro or anti anything particular. I just think I like to use the simplest possible tool. And if you're doing this approach of having the I/O at the ends and at the beginning, then something simpler like Dapper works perfectly well, and you don't need to have the whole Entity Framework thing. But if you're happy with Entity Framework, then go ahead. Entity Framework assumes that all the records are mutable, I think. And so if you're working with F#, that's also a bit of a pain point, I think, because F# assumes that everything is not mutable. And again, so there's just a little bit of a collision between the different ways of thinking about things. Entity Framework is a very object-oriented way of thinking about stuff. Okay, somebody just implemented shuffling a deck. Let's see. There we go. Let's see if I can open this up here. Oops, it's not working. I need to author. I'm not authorized on GitHub right now. Oh, there it is. There we go. Yeah, I'm not sure whether randoming sorting, I don't know. You know, if you're into shuffling, there's a whole bunch of logic about correct shuffling. There's the Diffie, I can't remember the various, there's a bunch of shuffling algorithms. So I personally would steal this from an algorithm book. Yeah, I think this looks like a problem. Yeah, Fisher-Yates, that's a good one. Fisher-Yates shuffle. This is the kind of thing where I would steal an algorithm from a book and not try and invent my own one. So there you go. That's all good. What else do we have here? Is there a minimum complexity that a project needs to justify using domain-driven design? And that is a question I hear a lot because people think domain-driven design is complicated. So I will just show you my little picture here, which is this picture. Oh, that's not the right picture. Where'd it go? This picture. So if you need to have a shared mental model, then you should use domain-driven design. And it's nothing to do with how big the project is. People think it has to be like a heavyweight project. I mean, I did a shared mental model for the card game, you know, in a few lines of code, and it takes about 10 minutes to talk about it. So it's not a heavyweight process. It doesn't have to be a heavyweight process. It's really the idea of getting everyone literally on the same page, everyone having the same vocabulary, the same common language. And it doesn't have to be a big process. Like I say, it could take 10 minutes and it could be documented on one piece of paper or half a piece of paper. So it's not about how big or heavy it is. It's about, do you want to have a shared mental model? And often, even for myself, the process of doing it for myself forces me to think. So I'm sharing the information with myself, you know, in 6 months from now when I've forgotten the project. You know, often when I write some code and I come back to it 6 months later, I was like, why did I even do that? And so if I do this, it helps me to understand what I'm doing. It's like writing a whole bunch of interfaces, you know, writing interface first program rather than just writing a bunch of code. So it's exactly the idea is you try and focus on the big picture first before you dive into the details. So I don't think it's anything to do with the size of the project. Like I say, it doesn't, the whole process can take a few minutes. It doesn't have to be it's not like a very heavy process at all. Right, Entity, you're having a big discussion about EF core, and I do not use Entity Framework anymore, so I do not even know how that works. So you can talk about it. Okay, what if you have a tree of business decisions that you need to look up pieces of stuff in the database? Okay, so that's a very good question. So what we're saying here is, if I go back to this one, what in my ideal logic, you load up all the database stuff and then you do some business logic and then you put it back again. Now, what happens if you need to make decisions in the middle? Like based on one piece of data, you load up another piece of data, and then based on that piece of data, you load up another piece of data. So one thing you can do is you can do what I call the sandwich model, where you do some database stuff and then you do some pure logic and then you do some more database stuff and then you do some more pure logic. And that's fine. As long as you keep them separate, because each one of these pieces is testable independently. But sometimes, you know, often loading everything up in memory at the beginning is actually quite fast. I mean, typically the performance, memory is not normally the bottleneck. Normally IO is the bottleneck. So if you have a whole bunch of things and you need to make a decision, yeah, it might be easier to load the whole thing up in memory and then just do everything in memory. And then once you've got your result, you save the result back. That's a performance-based thing, and it just depends on your domain. Depends how many things you have to choose from. But often, like I say, doing one database hit and loading up everything in one go can actually be faster and easier to test. It depends how big your graph is. Yeah. If you have a small graph, I mean, if you have like 1 million customers, obviously that's complicated. If you just got, you know, a couple of hundred, it might be easier to load them all in memory. Now, the other thing is that this is domain. People say, well, you know, should you use domain-driven design for everything? And I would say only for things where the domain is important. Now, if you're doing things like machine learning, where everything is basically matrix multiplication, or if you're doing game programming where you're trying to do, you know, rendering triangles on the screen or something, the domain is not the important thing there. You know, if everything's a matrix and you're just multiplying them, there's not a lot of domain logic, right? You're not trying to capture the domain. Everything's just matrices that you multiply. And then if you're trying to do video rendering or you know, graphics shaders or something, there's not a lot of domain logic. It's all about how fast can you do this kind of stuff. Or if you're doing signal processing or something, there's not a lot of domain logic. So this is not applicable for all things. Mostly it's for business logic, where most of the stuff is this kind of business logic, and there's some database stuff. So I'm not saying it should be used for everything all the time. So if you're doing like if you actually have a very large social graph, like your Facebook or something, yeah, the domain logic is not very complicated. It's really it's really traversing your graph of objects and trying to find things and whatever. It's a very different idea. And sometimes database driven design is good. If you have a big database, like a data warehouse or a data lake, and you're doing lots of joins because you're writing a report, find me all the customers that spent this much money in this year, that bought this product, which didn't buy this other product. I mean, that's kind of reporting or data science or data warehouse, all that kind of stuff. That's just really hitting databases. Again, so there's not a lot of domain-driven design there. That's really doing a lot of joins on tables, and that, in which case, use databases. That's what databases are really, really good for. Yeah, graph databases are good for that too. Graph database advocates say they can reason with non-techies in the same way. I haven't tried using graph databases myself. I've never really had a need for them. Most of the stuff, to be honest, I normally use relational databases for everything. I'm old-fashioned that way. I find that relational databases, they're my default way to go. If I run into a problem that can't be solved, then I might look into using a graph database or a document database or something. But typically, I start off with relational, just because they have a lot of benefits. They have consistency. They have the ACID stuff that document databases don't have. So, yeah, that's my basic thing. Right. Okay. I think we're running out of time. So we're going to stop, I think. And I'm happy to answer questions on Twitter. And let me just go back to my last slide here. I'll just put these links if anyone's interested. Training. So, okay. So thank you very much, everyone, for coming. And I'm very happy to be able to talk to you. And I hope I can come back and talk to you again sometime. That'd be great. Maybe in real life, really in Barcelona.